Okay, well, welcome. It's been fun. With a capital F and a U. We're trying to make the Firefly work, and I've been driving it around, and it has power. It's delightful. Oh my gosh. The original 305 TBI engine that was in here is rated at 170 horsepower and I think 245 foot-pounds of torque. And it pretty much runs out of steam at 4,000 RPM, give or take. One of the things I didn't like about it was exciting when I first got it on the road, and then it was like, it's all right, I need more power. And then it became, that's not a bad commuter, really. I mean, I could drive this every day, and it's not bad. But, you know, you need more power. And horsepower is kind of like the crystal meth of things. You never really get that same high again. So, a while back, a number of months ago, I didn't like you behind somebody on the highway doing the speed limit, you pull up past, you punch it downshifts, and then upshifts. Like, you're not even finished pulling out, and it's already upshifted, because it was shifting at about 4,000 RPM. I didn't like that. I thought we could use a bit more. So, I took the governor out of the transmission, and I cut a bunch of the weight off of the governor weights, the same as what I did on my daily driver, which shifts around 5,200 RPM. So I put it back in here, cut the same amount of weight off, and off we go. And this thing, you pull up and pass, and it would downshift, and it would run out of power, and it would fall on its face, and then the engine is just kind of rowing as fast as it can, hoping to eventually have enough speed that it would upshift, and then it would upshift and throw you back in your seat, because now it's suddenly making power again. And it took a short amount of time, and then there's a ticking noise in the engine, like I wrecked something. But, you know, a good way to kill a 305. So I put in a 350, which looks pretty much the same as the 305 that came out of it. It's a 4-bolt main, 397.010 block. The high nickel content, good block. It's original bore. It's never been bored out. The crank's never been turned, but it was a good solid motor. So I honed it. The bearing clearances were a bit big, so I got 001 undersized bearings, and so the crankshaft all fits at 0.002. Fresh rings, fresh hone. These are 882 cylinder heads, which in the wonderful world of Chevy, these are number 10 of the top 10 heads. That's right, they are the best. No, these are the worst of the best heads. So, yay. Everything fit right in there. This is Holley big bore, I think it's 52 millimeter throttle bores, way bigger than the original ones. I stacked a couple hole saws, so a 1 3/4 inch hole saw would follow the hole inside there, and a 2-inch hole saw would cut new holes. Turns out there's a water jacket inside that intake manifold that you don't know until you hole saw it open. So then I got another intake manifold and just die ground the thing, cut it big enough to just fit. I'm running the GM injector pod on the Holley base because the Holley injectors are notorious for being awful. I had modified the fuel pressure regulator inside the throttle body, but I wasn't able to get it to be consistent. I'd set it to 18 psi, which should feed about 340 horsepower, and it would be 18, and then I would go down, and like the next time I drive it, it's at 15. And then I'd set it to 18, and then it was 15, and I'd set it at 18, and it was 13, and I just kept chasing it and chasing it and chasing it. I did a whack of stuff. Excuse me. I even took, this is the spring out of it. This is the regulator spring. You can shim it. I just made a stinking shim like that, and I had set screws. This was the screw that went underneath, so I could adjust the pressure higher, and I just found it not consistent at all. I machined this, which had a fuel pressure gauge, so I could check the fuel pressure, but I made it out of steel, which then I thought, well, that's dumb, because that's just going to rust, and then I'll get rust going through my injectors. So I machined another one out of aluminum. And it was running 18 psi, took the gauge off, made this out of aluminum, put the gauge on, put it in, and now it was 30 pounds of fuel pressure. I give up. So I took that apart. I took the regulator out and just made it solid, not solid, but whatever. And then I have this aftermarket guy right here. It doesn't have to be vacuum referenced, although you could, especially if I can't get it to run lean enough at idle. I could run this to tap into the vacuum hose and then have lower pressure at idle, but whatever. I'm sure it'll be fine for now. So the fuel from the tank goes into there, comes out, goes into here, and then goes back to the tank. In the gas tank, I have a fuel pump from a 95 or a 96, might be a 96 Vortec V8. Apparently it fit in, I mean it did. They said that the internet magic says that the 95, 96, whatever, Vortec pump will fit in there and provide the pressure and the fuel that I need. And I needed 18 psi on the factory pump, can barely even fart that. So that's the engine in there. I have run into some cooling issues, and partly the issues might just be because it's summertime in the Okanagan and we've been pushing 98 degrees in Fahrenheit for you Americans, or like 36, 37 degrees up here in Canada, and I've been running some heat issues. So this radiator was from a Ford Ranger pickup, a V6 Ranger, and it was a cross flow, and I made my own tanks, and I made my own thingy, so the fan would go on there, and it was fine in the fall and in the spring, but in the summer it's just not quite enough. But you can't really fit much bigger fan in here. You can't really see it too well, but I put in some plastic in here on both sides just to stop air from bypassing. I want the air to go into the rad, so I've blocked that off. I also did a thing that, hopefully you can see this. Shaky. So I made a little plastic kind of air dam. I don't know if that's even going to show up for you. There's a little plastic air dam down there, kind of like the F-bodies did back in the 80s, to catch the air underneath and shoot it up through the radiator. And the other thing I figured is because I cut the cowl out to fit the engine, the windshield's the high pressure area, so I figured air is probably hitting the windshield and being jammed into here. Well, any opening in the passenger compartment is sealed off because I don't want engine fumes in the passenger compartment, so there's no fresh air getting inside. So I figured maybe air's coming in here and pushing it against the rad, negating any airflow in here. The fenders are pretty open. You can see the openness on the inner fenders here, so that shouldn't be the issue. But I figure that might be. So I've taped it, and it seems to be better, but who knows. If I do stick with this, I'll just get some more ABS plastic and put it underneath and zap strap it, so that at least it looks neat, but it's blocked off. So I got the tape so far. Other than that, the engine is skookum. It's got a Lunati cam in it, roughly a 256, 262 cam, and there's not too bad of an idle. The idle's really pretty smooth and sedate, but boy, this thing pulls. I've had it up to 5,200 RPM, and it scoots nice. It doesn't fall on its face at all. To make this work, we've got that's the original 5-liter throttle body injection computer. I have Megasquirt on a shelf that I can use, but I have this. The chips are like $5. So for, I forget, $100, give or so, you got the Burn 2 from Mopes, and then I unsoldered the chip socket, pulled out the chip, put in the adapter, plugged in that chip, and then now I think I'm up to 25 different burns to try and get this thing tuned properly. That's been a bit of an ordeal all by itself, because why not? We've got USB to OSB, yeah, chipboard, that's what we're doing. USB to serial port adapter that I bought when I was doing Mega Squirt on the Super 7. I made this out of some adapter when I was gaming Quake 2 in my townhouse way back in the day, and I hooked two computers up with a serial cable because I'm old. But I just took this apart. Inside this is the Win ALDL adapter thing, transistor, I think a PNP, and a couple resistors, and then now that, through this cable, plugging into the ALDL, can data log and record everything that the computer's doing, so that's pretty cool. I didn't get the extra to burn chips on the fly, so I data log, and then I mess with this. So this is Tuner Pro. I'm pretty impressed with it. It's free, but for like $30 you can have it fully registered. But it's pretty cool. The thing with GM computers is that they're all programmed in hexadecimal, which I don't speak, but guys will hack them and have a mask so that you can actually talk to the hexadecimal, and so this is what we have here. The mask for this ECU is $4D, yay, and this is an 8063 chip. Well, it was an 8063 chip. Good news, nobody really messes with those at all. So there isn't really the knowledge base for this ECU as you would with, I think it's a 7747 or better, if there is such a thing, throttle body computers. But this is the one I have. It was only 1988. It's pretty Spartan, and it's causing some issues. One thing you want to do when you're tuning is turn off wideband so that the computer isn't messing with it, and you can get your VE tables going the way you want them to go. If I go to fuel, blah, 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 where are we? Fuel meter, and get the main VE table, load that up. I got spark control, and I've gone through this thing and I've taken out everything I'm not using. Like I've deleted EGR, I've deleted the vehicle speed sensor because the transmission doesn't have a vehicle speed sensor. I've deleted air injection, I've deleted the charcoal canister, and I've turned off all the stuff that I think I can find, assuming that I'm finding it all, because there's a lot of stuff that just plain doesn't work quite right here. But whatever. I don't fit in this car very well. All right. So, thing with this computer is you get a spark table of what your advance is supposed to be, and this computer will set up your spark tables for up to 3,600 RPM. And then there's like an adder, so if you're going above 3,600 RPM, you can go into here and it'll change things, it'll add to that. And then it'll add spark if you're on power enrichment, it'll add spark if the torque converter's on, it'll add spark if you're cranking, it'll add spark if the EGR is on, and all these things I've deleted because I just want this. So this is done up old school small block Chevy with useless heads like the 882s, roughly 36 degrees max, and I've tuned this, or I've timed it to be kind of what I want in the old school way of having like 15 or 16 degrees base timing, and then full manifold vacuum giving me another 12 degrees of vacuum advance. So at idle, I'm cooking at about 28 degrees at idle. And some of you guys are going to be, oh my gosh, no, you can't run that much timing. Leave a comment down below and tell me all about it, because I'm not going to read that. In some of it, like I'm a child of the 70s, we were taught to set it at 16 degrees and then have ported vacuum advance so that when you come off of idle now, you've got your vacuum advance. Apparently, that was done for emission controls, but back in the bad old days, full vacuum advance, which makes sense. If the throttle's not really open, you're not filling the cylinder, it's going to be harder to burn all that stuff. You might as well give it some advance. So that's what I'm doing. This is how I run my daily driver. Lots of advance right from the get-go. And that's fine. Good throttle response is pretty decent. So it's a lot of spark advance here. This is 30, 35, 40 kilopascals. This is where it idles. This is where it cruises. And then full throttle is mostly here. You don't tend to run at 400 RPM in full throttle. And if you do, you probably don't want a lot of timing. And you're not typically going to be 3,600 RPM and cruising, although, maybe you're downshifting or something, or slowing down because the fuzz is pulling you over. But whatever. That's my spark table on what I think this engine may want, and I'll be proven wrong in a second. Leave a comment below to prove me wrong. The VE table, which is like your volumetric efficiency table, this is the magic of how much fuel the computer thinks that you need to have. Generally, you're not going to need a lot of fuel when you're idling. You'll probably need more fuel at full throttle, and there's everything in between. This table stops at 3,200 RPM because it decides, this wonderful computer right there, it says, oh, if you're above 3,200 RPM, you're probably wanting power enrichment mode, and we're just going to go rich. So it goes rich. This is economy because generally if you want economy, you want to stay below 3,200 RPM. And then in the fuel section, there's a lot of things you can screw with. Where is it? Excel enrichment, cranking and starting. This is kind of fun. I still have to play with this a little bit. These are the air-fuel ratios that you want. They were like 6-to-1 or 7-to-1 or something silly. And I had to keep the throttle open a little bit to just get the thing to run. So I've been leaning this up. I got it to 9. I'll probably go to like 10, 10.5, so that it fires by itself just fine. But that just takes a bit of screwing around to make it work. What did I want? Power enrichment, wide open throttle. So what they say is for power enrichment, the computer kind of looks at your last table and whatever RPM, I guess here, say 3,200, and then it just keeps adding fuel or something. I have a sneaky suspicion that it's not using the oxygen sensor, so it's just going to use math. In here you tell it an injector constant, so I've told this that this is how much my injectors flow, here's how much pressure I'm giving it, this is roughly how big the injector is, and so now when it does its math, it knows how much fuel it should be getting from the injector. That's what the air-fuel ratio I want to get for full throttle, and it does math and gives me that fuel at the various RPMs. And as long as I have 18 PSI, yeah, it's giving me the right fuel at full throttle. But when it starts losing fuel pressure, it's just disappointment all around. So this has been interesting, and I'm still some issues going on with this. Namely, one is I'll be driving it around, the computer thinks it's lean. The computer thinks it's rich. It's reading the oxygen, the O2 sensor. It thinks the engine's running rich, so it pulls fuel. But then the engine is going into lean, misfire, and surging and driving poorly, which is telling me I don't have enough fuel, but it keeps pulling fuel. So if I let it go and I lean it the way it says it wants to go, it doesn't run at all. That's not normal. Don't even look at that. And if I fatten it up, it still pulls fuel, and it's even running leaner. And I fatten it up more, and it's still pulling fuel and running leaner. And I fatten it up more, and it's even leaner than it was before, and that's making no sense to me. So I've been fighting that. The other thing is I've been trying to turn off closed loop, where it looks at the oxygen sensor, and I can go and change stuff in here, like I can set the integrator, which is just Google it for figuring out how much it wants to. This is so it can figure out what to do with the fueling. So the enable minimum map. Well, okay, I've set that to be. Oh, come on. There we go. I've set that to be, okay, go open loop when it's 104 kilopascals, which is like below sea level. Same thing, the enable minimum RPM. If it's RPM, okay, turn on open loop, or closed loop rather, when I'm at 6,300 RPM. I'm not going to rev that high. I'm not going to see those kind of vacuum levels. So it shouldn't turn on closed loop. But guess what? It's turning on closed loop. So it's frustrating. And there's other parts trying to tune the thing. There's, where is it? BLMs, block learn, multipliers. They're somewhere in here. There we are, right next to me. Yay. So these are things that the computer, if it's happy, it'll have a magic number of 128. If it's running rich and it needs fuel, or it needs to kill fuel, it's going to lower this BLM number. It's math, and this is how it leans it out. Or if it doesn't have enough fuel, it goes higher than 128, and that's math to make it give me more fuel. But I've set this to be 128. It's supposed to be 108 because as I'm running, it pulls fuel until it pulls all the fuel and it runs like crap. So I've limited this so that it cannot pull any fuel at all, and yet it still tries to. So I don't know. This is annoying, and I don't really want to learn hexadecimal just to make this thing run. So I'm mucking with it. I'll get it working good enough, or I will sell this car for cheap because, well, no, I guess I could put a Rochester on it. That would probably work too. So, yay, good times. Laptop fun right there. Yeah, Windows XP, why not? Driving it around, it would run lean, and then it would pull all the fuel, and then it would run like crap. And I don't know if you're going to be able to see this. Way down in here on the header, it blew the header gasket out. Well, that's a problem because the header gasket is going to let air through, and when air goes through, the oxygen sensor is like, oh, dude, we're totally lean. And then it runs like crap, I guess. I don't know. So that header has to come out again, because why not? It only takes me like an hour and a half to do a header, I think. No, sorry, it was like 2 hours to do plugs. So, yay, that's going to be a barrel full of fun. And I don't want to do it right now, but that is going to have to come out and get a new gasket. And then maybe that'll fix my tuning issues. Probably not, because why not? So yeah, we'll get an update at some point on the header gasket. I was using, I tore a piece of the header gasket packaging off because I thought they were really good header gaskets, but I'm not sold on them anymore. So I don't know. I put it somewhere because probably with all my 10mm sockets. So I will check out. I'll be picking up another gasket tomorrow morning. Try to pull the header out, and then we will get the new gasket in and see if that makes a difference. Because why not? I can always use some more happiness here. Anyways, good times.